When you all first started factoring, you were taught start with 1 in that number, right? Like 1 in 243. Well, that's not going to do us any good today, so we're going to skip that one. Does 2 go into 243? Does 3 go into 243? You could always just calculate 243 divided by 3. Does it? Very good. Very nice. 3, oh darn it. 3 and 81 are factors of 243. And then you try 4 and 5 and 6 and 7 and 8, and you'd finally stop at 9 and see that 9 and 27 are, and then you might keep going, and I think that's actually it. Those are all the factors, other than 1 and 243, that multiply to get 243. Now, what we're going to be doing today are solving problems like this. Now, this is an extremely basic example of what we're doing, like that. We're going to be doing the square root of 243, not as a decimal, but we're going to reduce it. So what you're going to have to do is look at these numbers and say which one of these, first of all, which of these are perfect squares? Because we're finding the square root.
81.
And 9, right?
Yeah.
But when in doubt, always go with the bigger one. If you go with the bigger one, you're going to save yourself a lot of trouble. So we're going to factor square root of 243 into, and yes, you can do this, square root of, I'm sorry, that's wrong. 3 times the square root of 81. What's the square root of 81?
9.
So this is the same thing as 9 radical 3. The square root of 243 is the same as 9 radical 3. Now it's extremely important that you grasp these early fundamentals because I'm about to kick up the volume 1,000%. Well, not really, but a lot of people see it that way. Okay. Questions?
So you multiply by the biggest number, and then the one that you multiply goes in the front of the radical.
The one you can actually take the square root of, yes, that square root goes in front.
So since you couldn't take the square root of 3,
It stays there, that's right.
But what about the 9 and the 27? Why did
Well,
you
see,
use them?
we didn't, because if this hadn't been a perfect square, I would have needed to have found one, which 9 was. But we always start with the biggest one. So we only need one pair of factors. We had to find the one with the biggest perfect square. Now, what if I had done this? Instead of the square root of 243, what if this was the 4th root of 243? Not quite as easy. You would still, well, rather than list off all the factors every time, what you can do is just start searching for factors. Now, just like a second ago, even if we didn't factor 243 first, what you could have done, because you know that your goal is to find a perfect square factor of this, so instead of just writing them all down, you can just start looking for perfect square factors. You say, well, does 2 squared or 4 go into this? Does 3 squared or 9 go into this? You would have said, oh, yes. The only problem with doing it like that is Nick jumped straight to the 81. If we had used 9, be like, hey, 9 goes into that, that's a perfect square, it would have gone into 9 and 27, and then 27 we'd have to factor again, and you might have to factor multiple times. But when it comes to a higher root like 4, here's what you want to do. We're going to look for a number that's a perfect 4th, and that's going to go into 243. So how you're going to do that is, and you might want to have a calculator today, or at least be sitting next to someone who does, or whatever. All right, here's how you will find perfect 4ths. Of course, after you do a few of these, you're not going to need to keep doing them. We are looking for numbers that form perfect 4ths. Like 2 squared is 4, that's a perfect square. A perfect 4th, well, what's 1 to the 4th?
25.
What? 1 to the 4th power? Just 1, right? So that's useless. What's 2 to the 4th?
Half.
Oh, sorry. 2, arrow, 4, 16. So we're going to start with 2 to the 4th, 16. Does 16 divide into this number evenly? We'll try it. 243 divided by 16. You're holding a calculator. No, it doesn't. So we're going to try a different perfect 4th. What about 3 to the 4th? 3 to the 4th. 81. Does that divide into this number evenly?
Yes.
Yeah, we just did that. We're finding a perfect 4th number. So here's what we're going to do. We are going to factor this, very similar to the way we did a second ago, into 81 and 3, except these are now 4th roots because this whole thing was a 4th root. Dadgummit. Okay, Now, that factors down into the fourth root of 3 to the fourth, which is what 81 is. That's what we just found out. And the fourth root of 3. Now, the fourth root and a fourth, those cancel. Cancel, cancel. And you're left with 3 times the fourth root of 3.
I'm confused.
Do you get where we got this?
No.
Do you get where we got this?
Nope.
On the calculator, we were looking for a number which, when taken to the fourth power, was a factor of our number, 243. So we tried 2 to the fourth, and then we divided it, and Jalen said, no, 16 doesn't go into this. So then we tried 3 to the fourth, which was 81, which does go into this. So we factored it into 81 and 3. Now we need to take the fourth root of those numbers. Well, that one doesn't have one, which is why it's still the fourth root of 3. But the fourth root of 81, as we just found from 3 to the fourth, is 3. And another way to punch that in the calculator, of course, if you found it, then you're kind of staring at it. Right here it says 3 to the fourth, so you kind of already knew what the fourth root was. But a way to punch this in the calculator is 81 to the 1/4 power. How do you punch that in the calculator? I'll show you. 81 to the 1/4 power. You have to put your 1/4 in parentheses. 3. So, we factored this down into dadgummit. We factored this down into 81 and 3. We were looking for the fourth root. And the fourth root of 81 was 3. So this became 3 times the fourth root of 3. And that's how that
3 from?
this one right here?
Yeah.
Because that is the fourth root of 81.
Well, how did you know that?
Well, 2 different ways. First of all, we had our factors, so I was hoping one of them was a perfect fourth. So I took, on the calculator about 2 seconds ago, 81 to the 1/4 power, which is the same as the fourth root. A fractional exponent is the exact same as a root. If it was a fifth root, you could raise it to the 1/5 power, a cube root, 1/3 power, etc. And we saw that the fourth root of 81 was 3 by putting it in the calculator. 3 to the 1/4 power. So we have factored this into this. Believe it or not, this is the hardest part of the day is the numbers. The letters are easy. When I start throwing variables in here, those are cake. They really are. Hardest part is finding the numbers for your roots.
I don't see where you got 3.
This one, again, when we first started on this slide, we were doing the square root problem, right? And we had 81 and 3 and 27 and 9. I needed one of those numbers to be a perfect fourth for this problem. In order to reduce this, here's the thing, and here's a hint. Okay, you're not just going to have to come up out of nowhere with these. When you see a problem, they aren't going to give you a problem that can't do anything. You need to know, hey, they want me to take the fourth root of this. This number is going to have some factor that's a perfect fourth. That's why they're doing it. They're going to try to make you find that number. So we had to look at all of our factors, 3, 81, 9, 27, and find one that was a perfect fourth. And we found that 3 to the fourth was 81, one of our factors. Now, it might help you to know that an exponent and a root are complete opposites of each other. You know how addition has subtraction, multiplication has division, everything has a counterpart? Well, roots and squares and things like that are the same. Like, what's 3 squared? What's 3 squared? Is 9. What's the square root of 9? 3. They're exact opposites of one another. What's 4 to the third in your calculator? 64. What's 64 to the third root? Or basically, you could just raise 64 to the 1/3. 4. They're exact opposites. So when we found that 3 to the fourth was 81, we could then deduce that the fourth root of 81 was 3. which is why we could pull that 3 out. Okay? We're going to do some more examples. Here's where this is going. We're going to be doing things like this. All right? Now, the letters, I promise you, are the easiest part. They really are. So, by the way, anytime there's a square root without a number, like a cube or a 4, what number do we assume that is? It's a 2, actually. A square root is a second root. A square root and a second root are the same thing. So we're going to look for the square root of all of that, but we're going to do it one piece at a time. What's the square root of 16? 4. Very good. Now, I taught this like 4 different ways to my second block because they kept wanting a different way. In my opinion, the easiest way to do this is to remember that a root is nothing more than a fractional exponent. Last week we did all kinds of things like this. Right? And what did we do? Just multiply the exponents? That'd be x to the 6th? Same thing. Same exact thing. We could look at this problem, well, we already know it's 4, as p to the 8th, now that I've already taken out the 4, q to the 7th to the 1/2 power. And all you have to do is multiply your exponents. Now, we have one more step to do after that, but
Where'd you get 1/2?
square root. If that was a cube root, it'd be 1/3. If it was a 4th root, it'd be 1/4, etc. So, multiply our exponents. What's 8 times 1/2? Is it a nice even number? Then 4 comes out. So that'll be 4 p to the 4th. What's 7 times 1/2? Yes. You take your whole number, 3. Now, when you... crap, I can't pull up my calculator. When you punch into the calculator, 7 times 1/2, it's going to say the answer is 3.5. If you hit math, enter, it'll put it back into a fraction for you. 3 1/2. The 3 comes out here. The numerator. This is if it doesn't divide evenly. Like 7 times 1/2 was not an even number like 8 times 1/2 was. 7 1/2 is 3 1/2. The 3 comes out here, and that's what you factored out of the root. The 1/2, remember, what is a fractional exponent? We've been saying it all day. It's just a root. The 1/2, we have to, this number, the numerator, stays, so that'd be q to the 1st because it's a 1. And that's it. You're done after this. 4, p to the 4th, q to the 3rd. And 1q stays inside because it didn't divide evenly. Q to the 1st. We're going to do, this is all we're doing today. We're going to look at examples.
With no homework?
Depends on what you get done in class.
I got lost. Yeah, I don't really.
We're going to do more. Let me show you what the book wants you to put for answers. That's exactly what we had. 4p to the 4th, q to the 3rd, square root of x. Now, we could go into why they put an absolute value around that, but I don't think it's really worth the time right now. All I want from you today is 4p to the 4th, q to the 3rd, times the square root of q. Now, let's look at another example. How about this one? Let's go crazy. How about 64, 64, we're going to make this to the 5th root. X to the 7th, wow, that's really bad. 7th, y to the 11th. We're going to reduce that. We are going to reduce this. Now, the exponents are the easiest part. You want to do those first? Yes? No? Maybe so? Let's do the exponents first. All right. I need somebody to do this for me on your calculator.
Do it.
Thank you, Nick.
I don't have a calculator.
Then you won't do it, but you can come get one. Who has a calculator that would like to help me out? Q, you want to do this for me? That's all right. I'm going to help you. We're going to do the letters first and come back to the number. Q, what is, remember, this is the exact same thing as 64, oh dang it, 64, x to the 7th, y to the 11th. That says 11. To the 1/5 power. This is the exact same thing.
So it's
So-
always to the 1/5.
Well, no, the denominator is whatever the root is. If it was the fourth root, it'd be 1/4. If it was the third root, it'd be 1/3, etc. So, Q, I need you to do 7. Remember, we multiply our exponents times 1/5. Tell me what it
Put a
says.
fraction in this calculator.
Put times, then use your parentheses buttons, and then 1 divided by 5. Yep. Now hit enter. What is it?
1.4.
Now hit. See the math button? Hit
What is
enter,
that?
enter.
Let me see that.
Oh yeah, you don't have it. Let's see. Where do you have fractions of decimal? Oh, so you have to reduce this.
Takes me again.
Okay, good.
It's 7
Second tab
times.
button reduces the weight. Okay, what?
What'd you say?
1 2/5?
Oh, it's 7
It makes sense.
over 5.
It didn't reduce it
I feel like
like yours did. Shh. All right, no big deal. 7/5. I really thought they'd reduce the fraction ports like your calculator did. All right, no big deal. You know, I bet there's a way on there. Let me see a calculator. I really thought they gave it to you as a mixed fraction. Math, fraction, dadgummit. How do you make it give it to you in mixed crap? Okay, no big deal. No big deal. In that case, since it won't give it to you in the fraction that we want, I'll tell you how to do it anyway. All right, you punch 7 times 1/5 into the calculator with what, 1.4? Take the whole number, 1. That's how many x's are going to come outside of your root. It was 1.4, so x to the first is going to come out, the whole number. Let's go and do the y. Well, no, we can't yet. The 0.4, right? Take that 0.4 and multiply it by the root number, 5. Do it. 0.4 times 5.
It's 1.4.
Well, I know. We already took the 1 out. Just do the 0.4 times 5.
4 times 2.
That's how many are left in.
How come you haven't worked up to 64?
We're going to do all that in a second. We're doing the letters first. Now, Taylor, 11 times 1/5, or divided by 5, however you want to do it. 11 times 1/5.
Where'd you get the 2?
How'd
Well,
you
let
get-
me finish this part, and I think maybe it'll make more sense.
How'd you get X to the... I don't really understand this.
Okay.
So you always have to put a 5 right there.
Only because it was a 5th root in the problem. Whatever this is going to continue throughout the whole problem.
Why'd you put your X in front of the 5?
Because we factored out 5 of them.
How did you do that?
Well, because, would you agree with me that x to the 7th is the same thing, and hopefully you will agree with me because this is what we did all last week, x to the 7th is the same as x to the 5th times x squared.
Yeah.
Yeah, okay. Well, these numbers are perfect counterparts of each other. So we could pull this one out and the 5's cancel and you're left with 1x.
Okay.
That's how that worked. Remember, I told you there's like 4 different ways to do this.
So why did you get rid of your Y? What'd you do that?
Well, we haven't. We're just working on it now. Now, you know what? Let's just look at it like, you said 2.2? Okay, 2.2. The whole number is how many y's you bring out. So that was 2. We brought 2 y's out. Now, I'm trying to teach you guys the easiest way to do this, but the problem is it's now a combination of methods. We took 11 times 1/5, got 2.2. The number in front of the decimal, that's going to be your exponent on the outside. Now, look at it like this. You took out 2 groups of 5. What are 2 groups of 5?
10.
10. Exactly. We took out 10 y's of the 11 that we had. How many are left?
1.
There you go. So there's 1 y left.
Where'd you get 10 from and why?
Why the question or why the letter?
What letter?
You said 10 and y. Y as in, why did you do that? Or y as in the variable?
Why'd you get 10?
Okay. Because basically this fifth root, this says you can only take out quantities of 5 exponents out of this. So how many 5s go into 11? 5, 10, and then we have one more, right? 2 groups of 5. 2 groups of 5 came out, which was a total of 10, and 1 was left to stay inside. Let's not even worry about the number just yet. Let's look at more of the variables. Let's look at another example with variables, just variables, and we'll come back to the numbers. Let's just go nuts. 6th root, a to the 13, b to the 19. Nope, 19. Okay. Okay, Brooke, how many 6s go into 13? 6.
2.
Thank you, Brooklyn.
2.
2. How much is 2 groups of 6? Yes. And look, 2 groups of 6 gives you how much total? No, I mean, what's 2 times 6?
What?
What's 2 times 6? 2 groups of 6 gives you how many total? 12. Good. We took out 2 groups of 6. Now, if we took out 2 groups of 6 A's, that's 12 total. If we took out 12 of the 13 A's, how many are left inside?
1.
1. A to the first is left inside.
So there's a mistake.
Well, we're doing that now. We'll do it one letter at a time. The B. Kate, how many groups of 6 can come out of 19? 3. And that's all I was saying earlier. If you did 19 divided by 6, it'd be 3 point something. That's all we were talking about with the calculator.
So is that going to be B3?
Yes!
Oh, okay.
Now, when it is B3, that means we've taken out 3 groups of 6, which is how many total? 18. Of the 19, how many are left?
1.
1. And then
Is that
you're
the
done.
answer?
That's the answer. A squared b to the third times the 6th root of ab. This became this.
That's easy. Yeah.
This is exactly what we were doing by doing it in the calculator. The only difference is instead of saying how many groups of 6, we were just punching in the calculator. 19 divided by 6 was 3 point something, 3, and then I was trying to teach you how the point something can be, but this is easier. This is fine.
I don't understand.
Let's do another one. Nick, you're going to help me with this one. How's about, oh no, what happened? New page? What just happened? Oh, that was weird. All right. We're going to go nuts. How about the 4th root of a to the 5th, b to the 11th, c to the 26th? Okay. Here we go. Now, if the part that's tripping you up is how many 4s and stuff can go into it, you can use a calculator for that. Now, Nick, how many 4s can go into 5?
Only 1.
You're right. Only 1. So 1A is going to come out.
Is that C to 26?
Yes, it is.
Alright.
Now, if we took out one group, A to the first, of 4, of the 5 total, how many are left in there?
1.
1.
So you have to use the number in front on all the other numbers.
The root number, yes, every time. Now, Nick, how many 4s go into 11? 2 evenly, right? Now, if you take out 2 groups of 4, how many is that total?
You left with 3.
Exactly. Exactly. How many groups of 4 go into 26? You can use your calculator for this. 26 divided by 4. Enter. What's the whole number?
7, isn't it? Or 6 maybe?
6. It's 6 point something. But 6. That's what I was trying to say earlier. 6. Now, if you took out 6 group of 4, how many is that total?
24.
So
24.
you got 2 left over.
Boom! Yes!
This is not hard.
This is easy. Well, it was hard 5 minutes ago. Okay. Okay. All we have to do now is put the numbers back in there, and we're done. Finished. And we've got like 6 minutes to do it. That's not true. We have all after lunch too, but you guys tend to not be as focused after lunch. Okay, so we're going to do the exact same thing, but we're going to throw numbers in there this time. How about the fifth root of 64, a to the 7th, b to the 9th, c to the 13th? Before we do the number together, you do the letters. Reduce the variables. We'll do the numbers together in a second.
So if you divide something and give you a decimal, what do you do? Because I did 64 divided by 5.
Don't do the number yet. Just do the letters right now. Just do the letters. The A, the B, and the C. We'll do the number. The number's different. Corey, you just got here. Do you feel confident in helping me out? No. No? Okay. Well, all right. Stephen, what do you say? What about my letters? What's going to happen to them?
A goes to A squared.
And stays inside, right? All right. Now B.
It goes to B4.
And how many do I pull out? What comes out here?
B1.
That's right. And the C?
Is that 13?
Yep.
C3.
Is inside. And how many come out?
2.
Very good. Very, very good. Very good. We took out 5 A's. 5 A's. We're left with 2 inside. We took out 5 B's. We're left with 4 inside. And we took out 10 C's. And we're left with 3 inside. Awesome. All we have to do now is the stupid 64. Now, again, when you see this root here, it's a really blatant hint. There is some factor of 64 that is a perfect fifth. Some factor. And when it's a number that big, it's going to be like 2 or 3 every time. So, what is 2 to the 5th power in your calculator?
32.
Hot diggity. Does 32 go into 64?
Yes.
What is the factorization of 32 and 64? What does it multiply by? 32 times 2. We've just rewritten the 64, that's a 5, as 32 to the 5th root and 2 to the 5th root. There ain't nothing we can do with this. The 5th root of 2, that ain't getting any smaller. The 2 is going to stay inside, which I would have put in the front, but I'm just going to put it in the back because I'm out of space. What is the 5th root of 32? What's 32 to the 1/5? 2. And that comes out. The part that can be rooted evenly comes out. The part that can't stays in.
Let's go to one.
No.
Where'd
I
you
know,
get-
me too.
How'd you get
Hey, we got
to?
chicken nuggets.
Well, because
No,
Q,
no, 32
Like
divided by
popcorn
1.
chicken or
You
whatever.
get 2.
That's what I-
32 divided by what? We didn't divide it by anything.
32 raised to the 1/5.
Q, what we had to do was find a number which, when raised to the 5th power, would divide evenly. Would multiply evenly. So we tried 2 to the 5th, and it was 32. 32 goes into 64. 32, as you just punched into the calculator, or should have, is just 2 to the 5th. The 5th root of 2 to the 5th cancels, and that comes out. But this one stayed in because it didn't cancel in any way. Okay. Questions on that problem? On that problem, no? All right. Here we go. Last example.
So did I.
How about this? The cube root.
You ain't right or nothing.
Technically, I'll be throwing something new into this last one, but not really. The cube root of 2 times, how about let's go with 81. A to the 7th, B to the 12th, C to the 10th. All right. Technically, we haven't looked at one yet. Technically, we haven't looked at one yet with a number out in front, but that's not really going to change anything. Not going to change anything. So, we are looking for a perfect cube number that is a factor of 81. So just start with the perfect cubes. What is 2 cubed? What is 2 cubed? 2 times 2 times 2. 8. Does 81 divide by 8 evenly? No. So we go to the next one. What's 3 cubed? That's squared. 27. Does 81 divide by 27 evenly?
Yeah.
Yes, it does. That's the cube we have to use. So, we're going to break 81 down into 27 and 3, which is the same thing as 3 cubed, which is 27, and the cube root of 3. Now, this is all we needed to do. The cube and the cube root are going to cancel, and this 3 is going to come up here and multiply by the 2. Bless you. This 3, there's nothing left we can do with it. It's going to stay here. So, what's 3 times 2? 6. Just because there was already a 2 there. Cube root, and the 3 is going to stay inside. Again, we broke this down into 3 and 27. 27 is a perfect cube. It is 3 cubed. Cube root of 3 cubed is 3, which comes out. That one just hangs tight because there's nothing we can do with it. It stays in. Now the letters. Pamela, what's going to happen with my A's? A to the 7th to the 3rd root. How many are going to come out? How many groups of 3 go into 7? 2. So A2 comes out, A squared, and that leaves us with how many inside? Muy bien. Let's see. Jared, how many groups of 3 go into 12?
4.
Very good. So 4 come out. How many does that leave for inside?
9.
Very good. That was a tricky one. None. All 12 of them came out. How many groups of 3 go into 10, Mackenzie? 3. How many stay in? Best Monday ever. Very good. 3 came out. 1 stayed in. And there's your answer. 6a squared b to the 4th c cubed times the cube root of 3ac. That's it. That's all I wanted to accomplish today. I'm going to give you 3 to do. You've got almost half an hour. And now they are going to do before you go. What? Okay. They are going to be due before you go. I'll give you one square, 1 cube, 1/4. Remember, if there's no number on the root, what do we assume it is? It's a 2. It's a square root. All right. How about 4 times the square root of 18 Yes, it's a 6.
Tom's job, JV.
Wait.
I'm gonna go up there to watch the video. Madeline might sound like our name, but I think I'm going to be
Okay,
What does that say?
that's to the 24th. All right, these are your 3 problems. They are due before you leave this class. You have 25 minutes. I will help you as much as possible.
That's just
And that first one, if you